All right, we're back. This is the second part of page 7 of Notes 24 in Calc AB, solving differential equations. And I think at this point we are pretty good at it. So we're going to be doing things kind of reviewish. I went back, I added in the decimals or whatever's the approximate answers. Well, I'm having trouble because 31250 is not a decimal and it's not an approximation. It's the exact value, just the simplified version of these things. Got them on the calculator last time. I'm a little afraid of the calculator now because of some technical difficulties and how it eats my time when that happens. But here we go. So this is the second problem on page 7. And we have a differential equation, dy dx equals 1 minus y over x. And we want to describe all points in the plane where x does not equal 0, for which dy dx equals -2. All right, so this problem is kind of as simple as it seems. We have dy dx, and we know dy dx is going to equal -2. So that means if dy dx equals -2, it must be that 1 minus y over x, which is dy dx, equals -2, which would mean 1 minus y equals -2x, or y equals, what am I doing? 2x plus 1. So I added 2x and added y, and then I switched them. So this is only true if x is not equal to 0. So now it says describe all the points in the plane for which dy dx equals -2. So I'm going to say it's all points on the line y equals 2x plus 1 for which x does not equal 0. So I think you should write a sentence there. So at every point in the plane that is on the line y equals 2x plus 1, as long as x doesn't equal 0. So for all points on that line, if we take them and plug them in to dy dx, we're going to get -2. So like, it's not asking me to do this, but I'm going to. So if I do dy dx such that, I hope this works. Now that I'm not like, I don't think it through when I say things like that, but it should work, right? I mean, that's the whole concept. So y is equal to 2x. Y is equal to 2x plus 1. All right, so I'm going to do 1 minus quantity 2x plus 1, and then divide by x, which is equal to 1 minus 2x minus 1, so just -2x over x, and then divide by x, -2. Check. All right, so that definitely worked, which is good because when I started down that path, I was like, yeah, that should work, and it does. So we also verified it, so good for us. Find the particular solution, so I need to know what the differential equation is. Find the particular solution y equals f of x to the given differential equation with the initial condition f of -1 equals 4. So there will not be a c in our answer. We're going to solve for it. So I'm going to start out, I'm just going to write the differential equation again. So dy dx is equal to 1 minus y divided by x. All right, so I got to separate and I have to integrate, but that coefficient there is -1. The coefficient of y is -1. So I think the best thing to do is to say dy dx is actually the negative of y minus 1 divided by x. And then I'm going to leave the negative on the right-hand side. I do that so that I don't mess up so I don't mess up anything really. But what I'm trying not to mess up is reversing the chain rule on the left side. So u substitution, it's a killer. I see people do it all the time. They leave out that negative. Now I don't need to worry about it because I already took care of it. So I'm going to write it as, so let's separate dy y minus 1. It's going to be -1 over x dx. And we're going to integrate and integrate. Okay. So this is looking kind of interesting to me because here I get natural log absolute value of y minus 1. Save the plus c for the right-hand side. Here I'm going to get negative natural log absolute value of x. And then plus c goes here. All right, so what are we going to do? Well, I'm going to exponentiate, right? So I definitely don't want to solve for c yet. I'm going to wait, solve for c after I've dealt with some natural log stuff. So I'm going to exponentiate and write it as y minus 1 equals a new value of c, and then e to the negative natural log of the absolute value of x. Okay. So I'm seeing one area of concern right away. Well, I saw it a while ago and I didn't mention it, and I should have. Look at the differential equation. You got x in the denominator, so x can never be 0. So already there's a domain type thing that we're going to have to think about. So since the initial condition has x less than 0, at most our domain is going to be x is less than 0, at most. And there might be other restrictions. So I'm going to keep going with my solution. I just wanted to point that out there. I think there's more I can do here. I'm going to say y minus 1 equals CE. Okay, so it's negative 1 times the natural log of my absolute value of x. I'm going to bring the negative 1 up as the exponent. So it'll be the natural log of the absolute value of x to the negative first. Okay, and then so y minus 1 equals c. E to the natural log of something is just that thing, that's a property of logs. So times the absolute value of x to the negative first. We could definitely solve for c now. So I'm gonna do that. I'm gonna use this information to solve for c. So I'm gonna say 4 minus 1 equals c times the absolute value of negative 1 to the negative first, which is just 1, so it doesn't really matter. So c is equal to 3. Okay, getting there. I'm going to bring this up and use this, feed both of those into this. So y minus 1 is equal to, I'm going to get 3 over the absolute value of x. And then I'm going to solve for y. Say y is actually 1 plus 3 over the absolute value of x. And now I'm just going to restrict the domain and say, comma, x is less than 0. Why am I saying that x is less than 0? We talked about it. Let's talk about it again. So initially, we have, I'm looking for something I can write with that'll make this make sense. So we have this, so x cannot be 0, but our solution needs to be a continuous function. If x can't be 0 and we need a continuous function, then we're going to have to choose either x is less than 0 or x is greater than 0. How do we make that choice? Well, we go over here and we look at this. Negative 1 is less than 0, so we know we're going to pick x is less than 0. So that's how I chose that. And I would say that this is fine. Like, you could leave your answer like this. I do think, first of all, I'm just going to highlight these so that it's a little clearer what's going on there. I think that you can go one more step if you want to. However, let me highlight this as a finished answer. I mean, this is good. I would accept this. What I like to usually do, if I can, is get rid of absolute values. There's no reason to do this, and it's riskier than it needs to be. But let me write this in a different color. Get out of there. Okay. Blue. If x is less than 0, then the absolute value of x is equal to the opposite of x. So that's a fact. So really, we could say it's 1 minus 3 over x, where x is less than 0. No matter what, we're going to need to include that x is less than 0 part, because there's nothing about that function that would prevent you from like going with x greater than 0. So we need that for the domain. I'm going to try to switch to the calculator and see if the calculator can solve this for us, just to see. I mean, it's always reassuring. The calculator will spit out an answer. So we're doing DE solve. Y prime equals 1 minus y over x. Do we have an and y of negative 1 equals 4 comma x comma y. So we get this. So that's really interesting. Oh, okay. So it like, why did it do the negative there? Why is it not giving me the absolute value thing? What if, so that's our answer, and that's totally fine. What if we did this? Well, this is like probably, ooh, smart. It's doing a smart thing. I don't really know how it's choosing here. So it's doing what's right. I don't know. So it's getting this. We need to restrict it because that's how you do it. And the calculator doesn't care about that, because the calculator is working on a different level. You know, it stoops down to our level sometimes, but it wants to be doing harder things. So I'm going to go back to the notes, hopefully. And you can take a look at them one last time, hopefully, and not just a black screen. So this is what we got for this. And if we scroll down, this is what we got for this. So for this one, I think it's important that you write the sentence at the end. So all of the points on the line y equals 2x plus 1 for which x is not equal 0, that's where dy dx equals -2. Then we checked it, and that worked out, and that was really good because I definitely hadn't thought about that ahead of time. So I am going to end this here, come back in the next video, and do a little bit more. So I will see you there.